This is Ms. Santos, and for this segment, we're going to be covering gas loss in action. The first one we're going to be discussing is Boyle's Law. If you recall from the last segment, we talked about how pressure and volume have an inverse relationship. And in the video, we use a water balloon that we filled with air. I'm going to rewind it up a bit. And we use a plunger to simulate pressure in the system. So as the volume is decreased, the pressure is increased. Okay. Now we're going to look at the inverse. So if we were to increase volume, pressure is now decreased. And that's why the balloon in that instance expands. So let's zoom in real quick, and this will kind of help you visualize what's happening in the microscopic level. So here's just talking about the inverse relationship between pressure and volume. And when we zoom in, we see that there's actually oxygen molecules inside the syringe. Like I mentioned before, the balloon is just for visual effects to see what's happening. But let's look at the gauges as the plunger is going down. As we press down, the air volume is decreasing and the pressure on the balloon is increasing. That's why the balloon gets squished. When we take a look at the opposite, we're increasing the volume when we're pulling out the syringe, and now the pressure around the balloon is decreasing. So this goes back to the same video that we looked at last week when I showed you guys how a vacuum works. So let's take a look at this cool example. So in the last segment, I talked about the Coca-Cola can experiments. This is actually something that you are more than welcome to do at home. Just be careful and use oven mitts when using this. In this experiment, a Coca-Cola can has water in it and it's heated until there's water vapor. The moment that it's put into cool water, it implodes. It's pretty cool. The next one we discussed was Lussac's law. In Lussac's law, we're taking a look at temperature and we're taking a look at pressure. Of course, also keep in mind that at this point, volume is not being changed. Okay, it may look like it is, but we're not taking account volume. It has to remain constant. For this experiment, they took 2 standard candles, a beaker, and this blue liquid. It's actually water with blue dye, and all it is just for effect, so you can see what's happening to the water. As you can see, the water gets pushed out at first, and then now, as the flame goes out, the water begins to rise inside the beaker. So let's take a look and zoom in and see how or why this is happening. So when we zoom in, we can see that the flame is on. There's oxygen particles inside the beaker. That flame is heating up the gas particles. So you guys see temperature is increasing. Okay? And as temperature increases, what's going to happen to pressure? Pressure is also increasing. So that's what causes the water to get pushed out of the beaker. So then after that, something happens, right? Obviously this is burning. I don't know if you guys saw in the previous video, there was smoke that formed inside the beaker. And it's actually a reaction between the oxygen particles and what's burning over here. So we actually start to create carbon dioxide, right? See that? Okay. And eventually when all the oxygen starts to change and it starts to combine chemically, the flame goes out. And then what happens is the temperature starts to drop. So this phenomenon that you guys just observed is happening because temperature is now being reduced. So the pressure starts to also decrease, and therefore the water starts to rise inside the beaker. Okay. And again, this is also something you can do at home. It's pretty cool. And for Charles' law, we actually explore to see what happens to temperature and volume. Keep in mind that for this one, pressure is constant, meaning it's not changing. When we take a look at a balloon, we notice changes when we add temperature, or we increase the temperature, better said. So for this experiment, a balloon was used and it was put into hot water. And if you guys see, it kind of expands a little bit, but then something happens, and this is because the balloon was very small. It pops. So the experiment is redone again, and this time with a much thicker balloon. And when it's added to hot water, it's placed in the beaker, the balloon starts to increase in size. Okay, and that's because as you increase temperature, so does volume. For this part, they placed that same balloon in the freezer, and although you're supposed to see something, but this one's a little hard to see. But in a bit, I'll show you guys a clip that kind of zooms in and gives a better explanation. So let's zoom in here real quick, and that would show you what's going on. So we take a balloon, and inside we have oxygen particles. When we add the hot water, there is heat energy transferring from the hot water into the balloon, and it's warming up the gas particles that are in there. So as temperature rises, the volume of the balloon increases, making the balloon to expand. That's what happens with gases. When we add or increase temperature in gases, they tend to expand. So this is something we actually learned when we talked about matter. Okay. So here it says it's showing when energy leaves the balloon and the balloon decreases in size. So the same thing goes if we put the balloon in the freezer. As we put the balloon in the freezer and temperature decreases, the gas particles are going to come a little closer. Heat energy leaves from the warm balloon into the cold fridge, and the volume is going to decrease in size. So therefore, it's giving it a direct relationship. As temperature decreases, volume is going to decrease. I hope that this segment helped, and we will definitely be exploring this further. And if you guys want to try this at home, definitely reach out to me. I have many ideas that you guys can try at home to explore gas laws. And if you have any questions, just reach out to me.